As we've discussed before, tags in a processor is just another word for variables. And there's two main types of tags. There are controller scope tags and local tags. Controller scope tags can be seen by going to the controller organizer and double-clicking on controller tags. These tags are available to every task, program, and routine contained in the processor. Any of these tasks, programs, or routines can write data to these variables or read data from them. However, there's another class of variables called local tags that are only accessible to the programs in which they reside. So you might ask yourself, why limit a tag to being program scoped? Instead of making all your data controller scoped, why not let any program talk to any piece of data? Well, we tend to think of things in terms of objects and interactions between objects. When you're driving your car, you want to turn the steering wheel, you want to press the brake, you want to press the gas, and you want to listen to music. You might not care at every instant while you're driving exactly what's going on underneath the hood, every single parameter that's happening to keep that vehicle running. You want to take a limited subset of data from you as an object and pass it to your vehicle as an object to say, here, drive this way. Everything under the hood, you want to take care of itself without you having to think about it. And the same goes for programming. Program scope tags can be broken down into one of 5 categories: local tags, input parameters, output parameters, in-out parameters, and public parameters. For this example I've created, we'll be using local tags and input and output parameters. A quick note about the upcoming example. What follows is a minimalist scrap of logic to demonstrate the value of interconnections, scoping, and parameter passing. In reality, there would likely be dozens, if not thousands, of local variables present instead of the few variables shown, and the logic of each program could vary greatly. Use this example as a simple conceptual framework. So the data that's set up here from my program has a barcode that's a double integer that comes in as an input into the program. Also has a command to process the code now, which is an input. It's a Boolean. I have 2 local tags that are just for math operation. This data never goes outside of the program. It's only local to the program. And then I have 2 outputs to come out of this program to enunciate code bad or code good. Now if I look at the logic I've written, I take my barcode, which is an input, and I perform some math operation to it. Generally, there's data encoded within barcodes, and you perform some kind of math to get that data out. The math that I've chosen here is strictly arbitrary. I'm subtracting 40, dividing by 2. When I have my process code now command, and the result of my mathematical operation is greater than or equal to 100 for some reason, I'm going to say that my code is good. However, if I have the command to process the barcode now, and my barcode is not good, then I enunciate that my code is bad. One helpful thing about setting up your program this way is I might not only have one lane where I need to process a barcode. I might have 500. I don't want to duplicate this code 500 times within a routine, but I can copy and paste programs. Let's pretend instead of 500 that we have 3 programs. Great. Now I have 3 lanes represented by 3 programs, each of which contain the same code and parameters. Now, next thing we need to do is address these input and output parameters back to somewhere where they're going to get data from. So I have 3 programs, one for each lane, that analyzes barcode data and returns results of whether that data is good or bad. Well, that data has to come from somewhere and go to somewhere. So just for the purposes of this exercise, I've put some other program parameters, public parameters, into my main program and written a main routine. The main routine is simple. When I examine my barcodes, if all of them are okay, light a green lamp. If any of them are not okay, light a red lamp. But I have to make this data in my main program talk to the data in each of my lanes. Let's do that. Let's start with barcodes. In my main program parameters, I have an array of 10 double integers. There could be 10 barcodes. I want to map 1, 2, and 3 over to my lane 1, 2, and 3 barcode. Let's go to lane 1. Here's my barcode input. In order to connect this, I'm going to go over here to my parameter connections and select new connection. At first I can only see my controller tags, but I'd like to show parameters from another program, my main program. Once I do, all I have to do is find my barcode and select barcode 1 and apply. And now this register is connected to the other. Let's do that quickly for the other 2 lanes as well. Okay, I've gone through and linked my parameters. I'll scroll through lane 1, 2, and 3, select the tags, and we can see the connections. Barcode, barcode 1, code bad to not OK 1, good to OK 1, process code now to examine codes. 2, same thing. Notice that array element 2 is selected in these instead of 1 because we're talking about lane 2. Don't worry too much if you don't completely understand the philosophy of what I'm doing right now. It'll become evident soon. Great, all my tags are connected. So let's see what happens when we go to download to our emulated processor. Opening up emulator now. We'll go to Communications, Who Active, select our emulated processor and download. My examine codes bit. It looks like every single one of my lanes is reporting not okay. That's a bad barcode. Let's go into the code. We can see that barcode is 0. Well, that makes sense because I haven't set any barcodes yet. After my math operation, a negative 20 is not greater than or equal to 100. So we turn on our code bad for each lane, which reconnects to my main routine in my results here in my logic. Well, just for fun and because I'm OCD, let's go into our main program parameters, go to the Monitor Tags tab, and for barcodes 1, 2, and 3, which are connected to my lane 1, 2, and 3, enter some large barcode numbers that should pass my algorithm. Here's some just random junk. We go back to the main routine and they pass. Let's see why. Barcode 1 should be 8996. If I go into my lane, my barcode is accepting that value because it's being passed across the parameter connection, and the logic inside of that program is flagging a good code. Same goes for lane 2 and lane 3.